No? Okay. Okay. So when we are talking about a multi-node storage system, you remember in our previous class we understood how storage controllers are connected to each other, right? We said there are multiple ways in which storage controllers talk to each other, how the data from one controller's memory within nanoseconds get transfers to the uh, memory of the other controller. So if it is a two node or two controller system, we also called it that it's called a HA pair, high availability pair, right? In such a system, connecting both the controllers is a very simple task, right? Either you take cables, there are special kinds of cables available. Either you take them and connect both the controllers to each other in the backend, or you put the controllers in such a chassis where the chassis itself has a very high speed interconnect over a you know board, over a PCB board. Both the controllers go and connect to those PCB board, and through that PCB board, the data traffic will flow between both the controllers. But when the number of controllers in a storage system go beyond just two controllers, then just to connect the controllers themselves, okay, there is a dedicated backend network. Emphasize on the word backend, because this network will not be used to communicate or connect to your servers or workloads, which is the front end. Okay, this network will only be used to transfer data in a low latency, high speed fashion between controllers. Okay, so that's the job of this network called as the cluster network or backend network. There are multiple names given to it, but ultimately it's the same thing. What it does, first, it physically connects multiple storage controllers to each other, and over this network, not just communication traffic between controllers, but also actual data from the memory of one controller is sent to the memory of other controllers and vice versa. Okay, so constant communication keeps happening between this kind of a network. And what is the characteristic of this network? It is one high bandwidth. Okay, so it will be in gigabytes per second. Okay, multiple gigabytes per second, and it is extremely low latency. When we say latency, we saw an example last time, right? When we did ping google.com, we saw few milliseconds of latency as the response time from those servers, right? Here it will not even be in milliseconds, it will be in nanoseconds. Okay, so within a few nanoseconds data packets get transferred across from one controller to another. So that will be the characteristic of such a network. Okay, sometimes there is a dedicated switch that comes in between. Okay. Now, here they are also showing that apart from this dedicated cluster network, you will have two other networks. Okay. One is called a management network, and second is called the data network. Okay. Now, what is the difference between these two? Data network is pretty simple, right? We saw the front end ports of the controller, and we saw that servers get connected either over a LAN or a SAN to the storage controllers. So that network over which servers are reading and writing data to the storage controller, that network is called as the data network. Okay, very simple. Okay, but though the terminology is simple, the architecture may not be that simple. As and when the number of servers get higher, number of switches get higher, it becomes a little more complicated than this, and hence we may need a separate network architect to actually architect the storage network also. Okay, so that is one part. Second part is these controllers also need to be managed, right? Why, what do I mean by management? So somebody has to get into the GUI or CLI. What is GUI? Graphical user interface. What is CLI? The command line interface. These are the interfaces through which you, as a human being or as a storage administrator, you will do certain operations on the controllers themselves, right? So you will tell the controller, okay, if I have to create a volume, what should be the size of that volume, how many terabytes it should be, whether it should be mounted over, SAN or NAS, okay, which are the servers which will have access to this volume, okay, uh, how should you protect it from disk failures? So all these kind of things needs to be configured, right? Because it's a fully configurable system. So in order to manage these storage controllers, in order to operate them and send certain commands to them, read certain management data from it, okay, you will need another network called as the management network, okay. Now this is not a high speed network, this is a very simple network. It will not even be in gigabytes per second, it will be in just 100 mbps also is enough, okay. And one management node per storage controller will be dedicated. So those dedicated ports will get connected to this management network through which you can operate the complete storage controller. Okay. And similar management ports will be there in every hardware of a data center. Okay. We saw there are multiple components in a data center, right? In our initial classes. So we knew that there are servers, we knew there are networking components, we learned that there are storage systems, just like how we are seeing now that a storage system is connected to a management network for initial configuration and continuous operations. Similarly, a network, a server, a router, a switch, every hardware device in a data center will have a dedicated management port and network port. And to that management network port, you can connect a network cable, you can connect it to a switch, and you can manage them. Okay, you can operate them. So that's the function of a management network. Any questions? Any questions? Okay, we'll shortly see pictures of storage controllers. Yeah, as I said. Okay, so here is where we are seeing the actual picture of a storage controller. Okay, and I will, break it down to you as to what exactly we are seeing and how to understand which is what. Okay, so let us understand the high level components first. If you look at the storage controller from the front, okay, you will see as if you what you're seeing in this first box here on the top. Okay, this is called a bezel. Bezel, bezel. Okay, it has got just uh, two functions. It is not an active component, by the way. It is just a fancy component. Without the bezel also the storage system will work, okay, perfectly. So basically this is used to have laminar airflow. That means smooth airflow. You see a lot of pores inside. Okay, it is to allow cold air to come into the system from the front, and you will also see that there is a small mesh inside. That mesh actually stops dust particles to enter the system. So this is its primary function of the bezel. And what these storage manufacturers have also done, they have started using this as their brand advertising place also. Okay, so apart from all these pores for air intake, you will also see the brand logo of that storage manufacturer on that particular bezel. So whenever anybody enters the data center, they can understand, oh, this is from which brand. So they understand, how to configure it and everything. Okay. So that's the function of a bezel. Bezel, bezel. Okay. The bezel of the controller will be different from the bezel of the disk shelves also. Okay. They are two different kind of chassis, and hence the bezel for both of them also will be different. Okay. One more reason behind it is the airflow intake required by disk shelves, which you see at the bottom, where you see the disk drives numbered, right? So these require more cooling and more, cold air intake, because there are mechanical components inside it, right? Apart from electrical and electronic components. So the amount of BTU per hour, we learned that, and you can see that in the specification sheets also, which you downloaded. Okay. That the BTU per hour of a disk shelf is more than the BTU per hour of the controllers themselves, because the controller chassis or the controllers themselves generally do not have any moving parts. Okay. Unless there is a controller which has got disks in the front. Okay. So it's like it is a storage controller when you look at it from the rear or behind, but in the front they have made provision to store disks just like a server. Okay. Then of course the BTU per hour of that chassis will be much more than just a disk shelf or just a controller shelf. Okay. So now we enter into a little bit more detail about what are the various components inside the storage controller. Okay. What we need to understand. So this part is clear. This is how the storage controller will look like from the behind. Okay. So as we have understood, they come in pairs. Okay. Also called as HA pairs. So that's why you have node A and node B. So when you're looking at the storage controller from rear, if they are aligned like this, then the one on the left is node A and the one on the right is node B. If they are stacked vertically, one on top of the other, then obviously the one on top is node A and one on the bottom is node B. Okay. So you will see different manufacturers having different kinds of controller chassis. What we are seeing right now is one of the models of NetApp. Okay. NetApp is one of the leading storage manufacturers in the world. You also have acknowledged that when you're doing your day one exercises. Okay. So this is from NetApp, okay, one of the basic storage controllers. This is how it will look like. Now, there are multiple components in the rear of a storage controller where we need to, connect different ports. So we will see them. So this we will come back a little later because this is a little complex to understand right now, scale up and scale out. So let me first show to you the various components. Okay, so this we have already learned. Uh, what is the different kinds of storage media? So if it is disk based, hard disk based, then only spinning drives will be there. If it is all flash, that means only solid state disk drives will be there. And if it is hybrid, then both kinds will be there. And we saw that hybrids are the one which are mostly used across the world for cost reasons. Okay. Because SSDs are, very high performance, but at the same time, very expensive. Okay. So one knowledge check for all of you. Can you read the questions and let me know which ones are the correct answers? Which two statements about a storage system are true? The two primary components of a storage system are storage drives and the storage controller. Servers connect to a storage system through the disk drives. The backend of the storage system has backend ports and the cache memory of the controller. And the storage system can have two storage controllers for high availability. So, which two answers do you think are true? Please put your answers in the chat. Can I see your answers in the chat? Okay, Anand says 1 and 4. Hari says 1 and 3. Okay, Shivani says 1 and 3. Okay, how about others? Prakash, Renu, Jagdish. Renu says 1 and 3. Jagdish says 3 and 4. Okay. Gopi. Gopi says 1 and 3. Prakash, are you not online? Okay. So let's see who all are right. I think most of you got it wrong
Sorry, it's
because
A and D.
A and D. mm, let's see. So the first one definitely is correct. We all know that the two primary components of a storage system are the storage drives. And yes, so Prakash is the only one I think who got it right. See, let me just go back and tell you why C is not correct. Okay? Because the cache memory of the controller is not in the back end of the storage system, it's there in the front end of the storage system. Okay? If we go back to this diagram, if you see here, the cache is in the front end, it's not in the back end. Okay? And this animated diagram which we saw after this, here it is just showing at a block level, okay, the entire storage system. Here, the demarcation has not been made in terms of what is front end and what is back end. It is just showing the operations, right? But since we have learned it in the previous diagram that cache actually belongs to the front end, so the cache memory will be there in the front end, okay? So now you are able to understand the importance of terminology here. What is front end, what is back end, what holds what. So it is very important. So we did a recap of all of this. Now, before we move on, let me go back to this particular diagram. Okay. And just hold on a second. Let me try to magnify this. Or just hold on. Let me find a spec sheet of NetApp. Just wait. No, let me Google it. Yeah, I got a picture. Okay. Can all of you see the screen? Okay. So this is another, you know, storage controller of NetApp. So I just wanted to show you the various components that are available. This is the model number that you see, FAS 8020. Okay. And very similar diagram is what we had seen in our course content also. Okay. So let me make you understand what are these various components. All right. So we understood that there is front end and there is back end, and there are front end ports, back end ports, and then there are management ports. Okay. So if you see here, for node management, a port has been dedicated. So this particular port is for node management. Okay. Then we understood that whenever we have multiple controllers, the controllers have to talk to each other, right? They have to talk to each other over a high speed network. And if there are more than two controllers, then they have to get connected to a dedicated high speed network called as the cluster network, right? So the port or the ports using which these controllers will speak to each other is this port. You see, for cluster interconnect, it is written this port. Okay. So you see the speed here, 10 gigabit Ethernet. Okay. Very fast. All right. Then we have backend ports. What is the function of the backend port? These are the ports using which the controller will start speaking and getting connected to the drives. Okay. To the actual disk drives and SSDs. Okay. Now, what are those ports? This is the backend ports. If you see here, these ports are entirely different from the other ports. The management port, the 10 gigabit Ethernet port, and this port. These are all different, which means the connector is different, the cable is different, the protocol that you use is also sometimes different. Okay. We also have a USB console. So if you want to connect a USB keyboard or a mouse and then operate directly, we can do that. Okay. And then here is where you also have the cache memory and LEDs. Okay. So NVRAM, non-volatile RAM. Okay. Non-volatile RAM, NVRAM is there inside the controller, which is nothing but the cache. Okay. And the LEDs. Now here is where it is a contradiction to what we had learned, right? We had learned that RAM is actually volatile. Whenever there is no power, whatever is the content of the RAM is gone. Correct? Then what is this NVRAM, non-volatile RAM? Okay, so let me talk about this a little bit. I'll share my screen. Sorry, I'll stop sharing. Let me on my camera. Okay. So today we are hearing a new term, non-volatile RAM, which is in contradiction to what we had learnt earlier. We learned that RAM, random access memory, is volatile. That means whenever there is no power, whatever content of the RAM is there, it is lost. Okay. Now, for a storage system, this RAM is very, very critical in order to have a no data loss kind of a scenario. Okay. Because as we had seen in our controller operations, every new write or new data that is coming into the storage system, before it gets permanently written to the backend disk drives, okay, either HDD or SSDs, it first comes and stays temporarily in the cache or in the RAM. Okay. And these storage manufacturers have to find a way to protect that new data that is coming into the RAM. Old data is fine. Old data is already there in the disk. Okay. So even if old data is lost in the RAM, no problem, because you can again read it back from the disk within a few milliseconds or within a few nanoseconds. But the new data that is coming in from this external world, which is your workload, that is very, very important. That cannot be lost, cannot be corrupted. Okay. Because if that is lost or corrupted, you have to ask the storage controller, sorry, the server workload to give that data back again. And if it happens multiple times, then that software which is writing the data, that can get corrupted or that can get crashed. So it's big implications. If the RAM or the data that is there coming into the RAM, the fresh, the new data, which is not existent in the storage system at all, that needs to be protected. Okay. So how is the big question? One method we have found is mirroring of the RAM from one controller to another controller, right? That is where the interconnect between the two controllers is used. I just now showed you which port is used to do that. Okay. I have not yet shown you the cables, right? I'll show you the cables also. But NetApp has found one more way to protect the data that is there in the RAM, because you can never predict when power will go away. You can never predict which component of the controller will fail to bring the controller down. Okay. Nobody can predict this. You can have averages. Okay. But for a specific controller, when it is going to fail, nobody can predict. Okay. Even if 100 quality checks have been done, still you cannot predict when a component will fail, even if it is brand new. All right. So NetApp has found one unique way of protecting the data that is there in the RAM. What they have done is they have a battery, a lithium ion battery, separately powering on the RAM only. Okay. Just like how you charge our phone by using lithium ion batteries, exactly the same way, the internal battery of a NetApp controller, okay, there will be an internal battery. That battery is meant to keep the power only for the RAM and nothing else. Okay. No other port will work, nothing else will work. Just it will keep the power on for the RAM. Now, for how long? Okay. They have, made some, research and studies and all that. And they found that if we can keep the power in the RAM for 72 hours, okay, for 72 hours, then within 72 hours anyways power will come back, or the component will get replaced, or you will do disaster recovery, something you will do, right? You will not sit quiet. So that, data will be there for 72 hours, and if the power comes back up again, then we reuse it. Or not, disaster recovery would have happened and we go to the other site, something like that. So there will be a lithium ion battery inside the storage controller chassis, okay, which is meant to keep the power on for the RAM of the storage controller for 72 hours. Okay, for 72 hours, which means 3 consecutive days. Okay, continuously it will keep the power on for the RAM. That is the reason why in this diagram they are saying that this is a non-volatile memory, NVRAM. Any questions about NVRAM? Let me show you. See, this is how the inside of a storage controller will look like. Okay. If you look at it at the back end, see, this is the management port. Okay. These are the front end ports. These are the back end SAS ports. Okay. And here is where the controller and the cache it will be there. You see this, vertical cards here inside where I'm putting my mouse pointer. This is the RAM. Okay. And next to it is the processor. Okay. If you remove the cover and look at it inside, see these long strips of transistors. This is the RAM. Okay. And these are the, this is the processor. Okay, which has got the heat sink on top. Okay, and this component, black component that you see here, that's where the battery for this RAM will be there. Okay, and hence it becomes a non-volatile RAM because it keeps the power on for the controller for 72 hours. That's the job of this controller. Okay, let me see if I find any other better picture. Yeah, this one looks good. It's clearer. Yeah, this picture is clear. So this is what will be there inside the storage controller of NetApp. Okay. So these green color chips that you see, these are RAM. Okay, high speed non-volatile RAM. This heat sink, what you see here, this is the CPU, and this long tube-like thing that you see, this is the battery for the RAM, and hence this becomes the non-volatile RAM. And here is where you can identify the various ports of the storage controller in the back end. Okay. So wherever you see, this symbol, okay, wherever you see this symbol, okay, like a small LAN kind of a symbol, that means that that's the management port. And wherever you see this spanner kind of a symbol, that means that that's the console port. Now, what's the difference? I'll tell you later. Okay. Then E0B, Ethernet. Wherever you see E, that's Ethernet. Okay. This is an Ethernet port. This is also an Ethernet port. Now, these ports that you see, C0A, C0B, 0C, and then here it will be 0D. Okay. These are the front end ports, the 10 gig Ethernet front end ports. But you see, these are not copper ports. Okay. These are fiber optic ports. Okay. We learned, right? There is different kinds of media, copper media and fiber optic media. So these are those fiber optic ports. This is how it will look like. And these two, this 0 and this 0B, okay, where link are written, LNK and LNK. These are nothing but the SAS ports, okay. These SAS ports are the ones that are used to connect this controller to the backend disk drives, okay. This is this is how it looks like. And there is an option to add additional ports. So you see this 1 and 2 written here on the extreme right. So here you can add more, they are called PCIe cards. These are like add-on cards, just like how you add an additional SD card to your phone. Similarly, you can add additional network ports to your controller. Okay. And those network cards can be placed in these slots. Slot 1, slot 2. There are two slots. Okay. So that is what you can do. And this is exactly how a storage system looks like. Any questions? Any questions? Anything that you did not understand? This is one more representation of a storage controller. This is a little old one. So you can see which are the front end ports, which are the management ports, which are the console port. Okay. Like this, you see the various symbols. Okay. And then you can see the various LEDs. You can see the LED for the non-volatile memory. You can see the SAS ports. These are for backend disk shelf connectivity. Okay. And all of that. Now, let me show you how the disk shelves actually get connected. So just hold on. It's called disk shelf connectivity diagram. Yeah. So this is one perfect example of how disk shelves get connected. So behind the disk shelf, you will see this kind of a you know plane. Okay. So on the top, what you see is the controller. So from the controller, cables will get connected using the SAS ports to the SAS ports on the disk shelves. Okay. Simple. Very simple. Okay. Nothing very complicated here. And it is actually that simple. There is no much of a you know, major thing to worry about there. And it's clearly indicated which cable will go where. So you just have to follow the instructions and put the necessary cables, in that. Yeah, this is one more example. Yeah. So you see, this is a diagram which is talking only about the backend cabling. All right. So the first rectangle that you see, that's the representation of the controller. And we saw that in the controller, the leftmost ports are the SAS ports, right? Where LNK was written. Okay. Those SAS ports are used to connect to the backend, which is nothing but the disk shelf, right? And this is exactly how they get connected. So if left hand side is node A and right hand side is node B, so node A port 0 will get connected to disk shelf, one of the ports. Similarly, node B's port 0 also will get connected to the same disk shelf, but to a different port, which means in the disk shelf chassis also there is redundancy. There is redundancy in terms of connectivity and there is redundancy in terms of power, as you can see in the diagram here. So just like how storage controllers will have dual power supplies in the chassis, similarly disk shelves will also have dual power supplies in the chassis and dual connectivities also, backend connectivities. Okay, so controller 1 gets connected to one of the backend ports, and controller B also gets connected using this dark blue cable as you see to another backend port. Then from one controller you can actually connect to the next controller, and this is called as daisy chaining. Okay, daisy chain means what? Creating a loop. Okay, so how? Because as you saw, in the controller there are only limited ports, but we also learned that hundreds of disks can be added and controlled by just two controllers. And we saw that every disk shelf can have only 12 disks or 25 disks, right? So how are we going to connect hundreds of disks to just two controllers? This is the way we do it. Okay, it's called as daisy chaining. So in daisy chaining, what happens? There is the first disk shelf. The first disk shelf gets connected to the second one. The second gets connected to the third one, so on and so forth. And how the first disk shelf got connected to the controller, now the last disk shelf in the loop gets connected back to the controller to complete the loop. Okay. So very simple. In backend cabling, the controller starts the loop. Okay, the first junction or the first termination of the loop happens in the first disk shelf. Then the loop continues from first disk shelf to second, from second to third, from third to fourth, and so on. Okay, how many ever disk shelves are there? Of course, there's a maximum limit, but that limit is pretty high. And whatever is the last disk shelf, from the last disk shelf, the loop will get closed by connecting back to the controller. Okay, so this is how the backend cabling will happen, and this is how hundreds, sometimes even thousands of disks can get added in the same loop to the same set of controllers. All right, any questions on the components of a controller? No? Okay, fine. So let's move ahead to the next module. Okay, so now we get into the connectivity part, and briefly we started learning about it, how various components were connected to each other. Now we'll go into the details of it. Okay, we briefly understood what is SAN and NAS, and we've also briefly understood what are the different kinds of cables available. Now we are going to get into a little more detail. Now here is a scenario, a customer scenario, okay, where there are these two people who are saying that we are a mid-scale company, healthcare company. They need minimum maintenance, but the storage should be scalable. That means you should be able to add a lot of terabytes, lot of petabytes, and it should be secure. And this will be used to store patient data and medical records. Okay, that's what the lady is saying on the left. What is the gentleman on the right saying? He is saying we are a small retail store that requires computers to run the billing application at the checkout counter to store the application data locally on just a hard drive. Okay. Now, what is the kind of connectivity required for both these scenarios? We are going to find that out because the gentleman on the right, that person's requirement is pretty small. Okay. Whereas the requirement of the lady on the left, it's huge. It's on the higher side. So you cannot have the same kind of a storage architecture for both. Okay. So we are going to find out which architecture suits what kind of a requirement. Right. So basically, as we have understood before, there are two kinds of storage connectivity. One is called as direct attached storage, and the second one is called as network attached storage or NAS. Okay. What is the difference between both of them? In the first one, there is absolutely no network in between, whereas in the second one, in NAS, there is going to be a network in between. Okay. In the first one, you directly use cables from the storage system, you connect it to the server. Okay, there is nothing else in between. Whereas in a NAS, between the server and the storage, there we are going to see some networking equipment. So the servers are going to get connected to the network, and similarly the storage is going to get connected to the same network, and that's how they talk to each other. Okay, so this we had already learned in the previous class. This is a reiteration of that. All right. Now, how the DAS environment will work? DAS means direct attached storage, where the storage is directly attached to the workload servers or the application servers. So in this example, we see typically how, and this is a very high level, uncomplicated diagram. Okay. So we see that in the data center, inside the data center. So this rectangular box you see, which is written as enterprise infrastructure, whenever you see such kind of a rectangular box, you can assume that customer or the architect is saying that this is inside a data center. And whenever you see this kind of a cloud and WAN written or internet written, that means that whatever is getting connected there, it is getting connected over the internet. That means it's not part of the local network. So this is how you start to understand the diagrams. Okay, the various diagrams. A router is symbolized by this 4 cross. Okay, so effectively what is happening, there are various end users like you and me connected over the internet. From the internet, depending upon the IP address and everything, it gets connected to this respective data center through a router, and the router routes the data packets or the request over a LAN to the respective servers. Okay. Now we need to understand how these servers will get connected to the storage system. And as I said, very simple, in a DAS environment, it's a direct connectivity that's going to happen between the storage system and the servers. But there are limitations here. Okay. I want you all to tell me what could be some of the limitations of a DAS kind of a architecture or connectivity. You can unmute and speak. Just
It is
imagine.
only restricted to one user. Like
Yes. Who
we,
is
we
this?
cannot
Prakash?
hurry
Hari. Yes. It is restricted to one what?
one company or a user. I'm not sure
Not one company or
within the
user, but
company.
only to that server.
Yeah. Mm.
Okay. So let's take this example, right? So the first storage system that you see on the top, it is physically connected only to this application server. So can this email server read and write data to the first storage system in a DAS architecture? No, it can't,
No.
because it's not connected. How will it get access, right? So absolutely right, Hari. Okay, that is the very good explanation. What else? What else could be some of the limitations?
Hello, sir.
Yes.
Uh, there might be some request and response delay.
Why do you say there could be delay?
It's a delay like It's directly connected, right? If many people access the data,
Hmm. Hmm.
if it is connected to the network, there might be some synchronous.
Yes, you are absolutely right. Very good, very good. Your name?
Chandra Prakash.
Prakash, Chandra Prakash. Very good, Chandra Prakash. Yes, you are very right. So, the amount of performance that you can get from a direct attached storage system will get limited to whatever bandwidth this single connectivity can provide between the storage system and the server. And as Prakash was mentioning, absolutely right, if number of users are high, this connectivity between the application server and the storage system may become the performance bottleneck. Okay, it may become the reason for slow performance of the application server, or in this case the email server also. Very good, very good. What else? You guys are learning good. I am happy. Just imagine how it will be, and imagine the various scenarios. You will get your answers. Last try. One more person. Anybody
Maintenance
else?
cost will be high for that.
Internet cost will be high.
Maintenance.
Maintenance cost. Okay. Why do you say so?
Because it is direct attached storage, we should be, place that on premises.
Mm-hmm. Mm-hmm.
So I
Mm,
think
no, no.
no. Okay.
No. This is not a valid answer. Maintenance cost for any storage system is relatively going to be the same, whether it is DAS or NAS. Okay.
Okay.
No, that is not going to be the correct answer. Okay, let's move forward. One important factor is storage utilization. Okay, so let me give you a very simple example. Let's say we have two people here. Let's say, yes, Anand. Anand, go ahead.
So, as of my understanding, since
Hmm.
it is a direct attached storage environment, it
Hmm.
will be directly connected to the server.
Hmm.
Whatever the data is left over, that cannot be used for another server.
Absolutely, yes. Perfect. That is exactly the problem with storage utilization. Correct. So, what
Yes,
example I
sir.
was trying to give, and Anand, you're absolutely right, is let us say, we have two people, Anand and Renu. Okay. Anand and Renu stay in houses next to each other. Just an example. Okay. Anand buys an SD card, Renu also buys an SD card. Okay. Both of them use 256 GB SD card. Okay. Anand puts that SD card in his phone, Renu puts her SD card in her phone. Okay. Anand is not much of a photo geek. Okay. He doesn't like photos, he likes songs. So he downloads songs and puts in SD card. Whereas Renu is very fond of taking selfies and pictures, so and videos and reels. So her content is that. But what happens sometimes, Anand wants additional storage. Okay, because he has downloaded some high definition songs and it has eaten up his 256 GB. Whereas Renu has some space left. Let us say Renu has some 50 GB left. Can Anand somehow make use of that 50 GB what Renu was using without disconnecting access to Renu? Is that possible?
No, sir.
Absolutely not possible, right? Because it's a direct attached environment. It's a direct attached storage. That storage is connected only to one server. So that SD card is connected to only one phone. One SD card cannot be connected to multiple phones. Correct? Hence, storage utilization or efficiency becomes a big challenge. Okay, if on the fly somebody else or some other server in the environment needs some additional storage, you cannot allocate it even if the storage system has some free space. Okay, so that's a big challenge in a direct attached storage environment. Okay, second thing, data loss. Okay, how data loss can happen. Now, so let us say that the storage system in which Anand was storing data, that SD card got corrupted and he could not back up his data. Okay. Okay. Is there any way he can recover that data? No, he cannot. Okay. But imagine a scenario where there was a shared storage system. Both Anand and Renu are writing to it and it is getting backed up. Even if something happens to one small portion of that storage, both Anand and Renu will still be able to read and write their data. Okay. So the situations of 100% data loss gets minimized if you are in a shared storage environment rather than in a direct attached storage. So if you are in direct attached, the chance of 100% data loss is higher. Okay. And because of these reasons, in today's world, rarely are you going to see any direct attached storage environments. Mostly you will see only shared storage or network storage environments. Okay. Any questions on direct attached storage? It is very simple. Okay. Now we get into shared storage or network storage environment. And yesterday or in the last class, we had a small glimpse of what is SAN and what is NAS, what is the kind of cable used, what are the various protocols, so on and so forth. Now we are going to learn more detail about it. Okay. So you see two diagrams here. There's a diagram on the top which says that it is using something called as FC protocol. You see here, FC protocol is written. And the diagram on the bottom, there is no protocol mentioned here. It simply says there is a file server here. Now, can any of you tell which diagram is SAN and which diagram is NAS? And maybe one or two sentences why.
The first one is NAS.
First one is NAS. Okay.
Yes.
Who is this? Can you please
Hari.
mention your name when you're speaking?
Hari.
Hari. Okay. Hari, you're saying first one is NAS and the
Yeah.
second one is SAN. Okay.
SAN.
Anybody else? Anybody else? Okay. Hari, looks like you haven't gone through the recordings well. Okay. No, that is not the right answer. The first diagram is that of a SAN. Okay. Storage area network. What did we learn about a storage area network? We learned that storage area network is a dedicated high-speed network using fiber optic cables and fiber channel protocol. Okay, which is meant only for very high performance applications, right? So this top architecture and connectivity that you see, it's of a SAN, and the bottom one that you see is of a NAS. Okay, network attached storage. Now we will find out the difference, but this is a reminder that whatever you learned in the class, please do go through the recordings also at leisure so that you reiterate what you have learned. You are not going to remember everything from the class. It's not possible. Our human minds are not built like that. So please do revisions. We are getting into more complex, concepts, and the more you revise, the better it is for you. So the top diagram is SAN and the bottom diagram is NAS. And we'll understand the difference between these two kinds of storage environments. Okay. Now, one thing you will have to understand, okay, here is, let me just stop sharing once. Yeah. The very important thing you have to understand here, and this is going to be the primary difference between a SAN and a NAS. Okay. And listen to me very carefully. Here we introduce a concept called file system. Okay. What is a file system? A file system is a method or a mechanism of maintaining and storing files on a storage system. Okay. There are different kinds of file systems available in this world. Okay. We will get into those details later. But effectively, what a file system does is it shows us or it gives us a method to manage the read and write operations onto files. Okay. Let me give you with an example. Earlier, when there were no digital records, how banks used to store all our transactional information. So for each bank account and bank account holder, there's to maintain a ledger. Okay. So consider that entire ledger book as a file. Okay. So I will have a ledger or a file with my name. Anand will have with his own name. Prakash will have with his own name. Shivani will have its own name, so on and so forth. Now, when there are hundreds of such files available, in a bank, how will you know that when a customer comes in, where to go and look for a particular ledger or a file? Any answers?
They depend upon the creating where they create an IDs, right, sir?
Yes, they create something called an index, correct? So in that index, they will know, okay, if this person's file is to be searched, this is available in this shelf, this row, this column. So anybody can just go pick it up from there, right? So this index that the bank is maintaining, it is called as the metadata. It is not the actual data. These are not the actual transactions, but this data, okay, this index helps you to search for data and maintain the data very efficiently and easily. Correct? Okay. Just like how we do searches in a dictionary, right? In a dictionary, when you want to go and search the meaning for a word, you don't go serially, right? A, B, C, D, so on. No, you directly go to the last page, which is the index. You find out which word you need to search for. You directly go to the page number of that particular, word. Go and read it. Exactly the same way, whenever a file in a bank needs to be searched, you don't go through all the records, right? You simply go to the index, okay, or the metadata, okay, and the metadata helps you to very quickly find where that particular record is, okay, and that exactly is a file system, girls and boys, okay. A file system allows us to effectively and efficiently store files and keep a record of those, in a separate area called as the metadata, and that allows to very easily read and write files onto the system, okay, onto the storage system. if if the file system has to manage a single hard disk, like in a laptop or a desktop, okay, so which means the file system is there only on a single hard disk, okay. But a file system can also be put across multiple hard disks, okay. Now, whichever entity in the data center, okay, or we understood there are so many components, right? There is a server, there's a network, there is storage controller, there are these hard disks, okay? Whichever entity in the entire stack in the data center, whichever entity has control of the file system, they are the ones who will be doing the read and write operations to the storage. Okay, let me go back a little. We understood what a file system is. Okay, file system is used to index files so that it is very easy to read, write, and search the files. Okay, file system can be placed on a single hard disk or it can be placed on multiple hard disks. All right, and whichever entity in the data center has control to this file system layer, that entity is responsible for doing the read and write operations to the storage system, because file system is the one which directly interacts with the hard disks. Okay, it exactly tells where the data needs to be stored on that magnetic platter. You remember our hard disk magnetic platter? Okay, you remember solid state disks, transistors, you remember magnetic tapes. Okay, so this file system keeps that, record of where what is stored. Okay, so that when you go and do a query on that file system, you exactly know, or the storage system exactly knows from where to pull that data. Okay, so we'll get into a little more detail of this later. Okay, but now you understand broadly that there is one more software component, okay, called as a file system. That file system is the one which knows where which data is stored, and if any new data is coming, where it needs to be stored, because it knows where the gap is or where the empty space is. Now, using this information that we learned, okay, it will be very easy for you to understand the difference between a SAN and a NAS. Okay, very simply put, if anybody asks you what is the major difference between a SAN and a NAS, you simply say, in a NAS, storage system has control of the file system, whereas in a SAN, storage control does not have access to the file system. The file system is there with the server or the host or the workload. This is the major difference. Okay, so in a SAN, this hosts, okay, these servers, they are the ones who are going to have the control of the file system. Okay, and hence they are the ones who will initiate read and write operations to the disk drives inside the storage system. Okay, inside all these components. Okay, so the file system resides here on these servers. That's the architecture of a SAN. Whereas in a NAS, the file system is there and maintained by the storage itself, and hence the storage acts as a file server. Okay, and if you see here, there is no mention of any host or server here. Why? Because since the storage system has control of the files and knows exactly where they are stored, directly users on the network can access these files without needing any server in between, any workload in between. Okay, and hence the protocol used is also separate. It's not this fiber channel protocol. Okay, because here servers are not accessing the storage. Here directly you and me as users are accessing the storage. Okay, so the protocol is different. Where we will explain or we'll learn later what is meant by NFS, what is meant by SMB, okay, and what it entitles. But the basic difference between a SAN and a NAS is who owns the file system. Once again, In a SAN environment, which is the box on the top, the file system is owned or controlled by the servers or the hosts. The storage system has no clue of the file system. Okay. And hence, you cannot access a storage system which is connected over SAN without a server or a host. You have to go through a server or a host. Okay. Whereas when you go to a NAS environment, the storage system itself has the file system, and hence it can control every aspect of reading and writing the file. Hence, you can directly access the content of the storage system through user desktops, laptops. You don't need any servers or hosts in between. Okay, directly over the network, you can read and write from the storage system. Any questions? Anything that you did not understand? No? Okay. So SAN is also called as block-based storage, and I'll tell you why. And NAS is called as a file storage. So in a block storage, each block is associated with a unique address, and this media can be either Ethernet, which is copper, or fiber channel, which is optical. Okay. And the characteristic of such kind of a storage connectivity is high performance and low latency. Okay, high performance and low latency. So if we go to the example of a bank, the core banking software, okay, which is responsible for all our banking transactions that we do in our savings account, current account, demat account, those kind of application workloads we will use a SAN using fiber channel protocol, okay, with high speed connectivity and low latency. Okay, those are the applications that will use this. Whereas in the same bank, when we want to store your KYC information, this KYC information is unstructured data, right? So that unstructured data does not need such high performance and low latency, and it is stored in terms of files. So you basically want the storage system itself to maintain the file system so that you can directly read and write from it. So that kind of an application workload is is or will be using a NAS. Okay. And what are the characteristics? This is mostly on copper only. Very few implementations you will see on fiber optic. Okay. It uses separate kind of protocols called as SMB and NFS. We will understand what it is. And as I said, because it is less expensive, mostly you will see these kind of storages from a volume perspective. Okay. In the this one, and you see this sentence in the top. The NAS storage controllers partition the storage and then own the file system. That's the most important part of this entire thing. Okay. NAS owns the file system. All right. And here is where additional reading is coming in. So I am going to share with you a PDF document. All right. In the WhatsApp group. Okay. This is the additional reading for SAN and NAS. Okay. Let me just quickly show you what it has. Just give me a moment. Okay. See, this is what I'm going to share with you on WhatsApp today, right? So it will tell you what is NFS protocol, what is SMB protocol, okay, and what is basically a file system, a SAN, okay, with diagrams and enough explanation and the various layers, okay. So today's uh, reading exercise or learning exercise will be for you to go through this material, okay. While you're going through this material, if you do not understand any particular term, okay, what I would request you to do is first do a Wikipedia of that term. Like you are getting a new term here called as a LUN. LUN means logical unit number. Okay. So what exactly is a LUN? You will understand. Anyways, we will learn it. We will learn it in our subsequent classes. But just do a little bit of a reading on it. All right. And then come to the next class. So if you have perfectly understood these concepts, okay, in across the world, any kind of a storage system comes, okay, in front of you, you will be able to operate it and manage it very easily, okay. You don't need much of a preparation to do that, okay. These concepts form the ultimate foundation or basics of learning storage systems, okay. If you understand these few words, few terms very thoroughly, any kind of storage model comes to you, okay, you will be able to do it. No questions asked. There'll be a small changes on how to access the storage, but the core concepts will still remain the same. All right. So please put in some effort in reading these concepts, and one by one we will be learning these in much detail in our next forthcoming classes. All right. While you're doing some reading, go to Wikipedia and learn each of those terms. Anyways, we are going to learn these terms in the subsequent classes. All right. And we are going into, a lot of complex things. We are going into nitty gritties. So kindly pay attention. Having said that, anywhere you feel any doubt, please feel free to reach out to me, either on WhatsApp or a message. Okay. Any questions for today? Whatever we have learned. No questions? Okay. See, I'm going a bit slow because these concepts you're hearing for the first time. I'm pretty sure no engineering college, at least in our country, teaches these. Okay. And hence, many of these concepts may be new to you, but don't worry. I will try to break it down in a very simple way and try to show you everything in form of a diagram so that it is easy for you to register. But having said that, anytime you feel something you're not able to understand, please don't keep it to yourself. Okay, express it, come out. No question is a stupid question. Okay, we are all here to learn, so you don't need to feel anything. Nobody is going to judge you, okay, whether you know something or you don't know anything. No problem. All right, please feel free to express yourself in this class. Okay, thank you so much, boys and girls, for your time today. We will meet again tomorrow. I will be sharing the recording and this particular PDF which I showed you as additional reading in some time. Okay. All right. Thank you, everyone. We'll meet again tomorrow. Bye. Take care. Have a good day.